Hello, kindergartners. Well, guess what? I was just enjoying a little bit of information that I read from my science book. I really enjoy having the science book because when I read it, it teaches me things called facts, things that I can test to see if they're true or not. And then I have lots of ideas that I can make predictions about and I can connect to other things that I know. So it's really helpful to learn from a science book. Well, I know you don't have this science book, but in your packet, you do have some copies out of the science book. Yeah, so you can read through this with your grown up, right? And you can find words in it that I'll be talking about. And this one right here is what we talked about yesterday about describing things. So you can look at that a little bit more. Well, today I'm going to share some with you from my nice fancy colored book, and then we're going to take a look at some of the things that are in our classroom that can help us understand this better. Now, when you're all done with this, after we're done talking, or even as I'm reading to you, you can go in our properties booklet, like we were in yesterday, and you can go to this page. It's from lesson 2. And it has 3 words at the top. This says solid, liquid, and gas. And you know what? The directions say to cut and glue the pictures, but guess what? Mrs. Finkel forgot to copy that page. So we're going to have to do the next best thing. You can draw a little picture of a solid under each of these. A liquid, and a gas. Oh, you're not sure what all that is? Well, no wonder. I didn't even tell you anything about it yet. Let's get started. And then if you don't already know about that, you will know something. Observing matter. What's the matter? What do you mean, what's the matter? I'm fine. Oh, what is matter? We better read and find out what that is. All right, here we go. There's a little experiment you could do in here. What is matter? A pitcher is made of matter. No, not like a pitcher that you take. I'm not talking about that right now. We're talking about this. It holds a liquid. The drink is made of matter. Matter is anything that takes up space. Matter has many tiny parts. Matter has mass. Huh? Mass is the amount of matter in an object. Oh, like how much space it takes up. Everything is made of matter and has mass. It sounds like they're trying to do a tongue twister, doesn't it? So matter is anything that takes up space. How about your brother? Does your brother take up space? Yeah, sometimes your brother might even get into your space, right? And you say, stop taking up all the space by me. Oh, sisters can do that too? I guess they can. What about your toys? Do your toys take up space? Yeah, they sure do. Sometimes your mom might say, it's time to give some of these toys to somebody else because they're taking up too much of our space, right? And then you might have to send some to someone else. Yeah. Okay. Well, there's all kinds of things that take up space. This book takes up space. It can fill up a shelf. It does. Let's read a little bit more about this. Describing matter. The things in this picture are made of matter. Oh, look at all those things must take up space. What shapes do you see? What colors do you see? How are the things alike and different? So when we talk about color and shape, it can help us describe. This bag is made of cloth. You can bend the bag. It still takes up space. The scarf feels soft. The scarf is blue. It's a way to describe it. The brown basket feels bumpy. The red boots feel smooth. What color is the round ball? Okay, what color is it? Yeah, Nevaeh, it is green. You're right. Oh, you're going to spell it too? All right, how do you spell it? Green. Right. Well, let's find out about more types of matter. All right. Matter comes in different states or different ways. There are solids, liquids, and gases. Oh, those are like the words on the page. Let's find out more about those. What toys do you see? All the toys are solids. A solid takes up space. A solid has its own shape. A solid does not change shape when it is moved from one place to another. Now, don't get tricked. You can have something solid and you can break it, you could smash it. Yeah, in that way, it can change shape. But if you are moving it somewhere, it doesn't change its shape. So if I take this piece of paper and I move it over here, it's still the same shape. Could I tear it? Okay, now it doesn't look like the same rectangle anymore. But just moving it didn't change its shape. We're going to talk about liquids. Because liquids and gases are different than solids. A liquid can change its shape. A liquid takes the shape of its container. A liquid takes up space. A liquid is still matter. Look at the different shapes a liquid can take. Aren't those fun to look at those jars? Yeah, they're different colors too. A gas can change size and shape. What do you mean gas is a liquid? Oh, you're talking about, yeah, the liquid gasoline, like the fuel that your mom and dad pump into the car. You're right. This is a little bit different. Let's see a little bit more about gas. Gas takes up space. Gas takes the shape of the container it fills. Air is a gas. Air is all around us. Air is matter. You can't see it, but it takes up space. That's interesting. Maybe we better look at some samples of this stuff and see what they're talking about. Let's move over here to another table. Oh, yeah, I better bring you with me, right? All right, come on. All right, now let's look at some things that are over here. All right, let's make a little room. We were saying earlier that a liquid is something that takes the shape of the container that it's in. There's a container that Mrs. Finkel likes. Do you remember having these? That's a cup. Let's see if I pour from this container into this container, if this changes shape. If it does, it would be a liquid, wouldn't it? Look at that. Yeah. When my pop was in this cylinder, it took the shape of this cylinder. But now it's in this cup, and it took on a different shape. If I tip it a little bit, see how it's changing? Its shape is changing. Very good. Let's take a look at another item that we think is probably a liquid, right? Let's use this clear. Let's take this cup from over here. All right, see this cup? I'm going to pour this liquid, or what I think is a liquid, into this cup, or this vase. Let's see if it changes. Oh, yep, you can see it doesn't look the same anymore. Let's try pouring it into here. This is a bucket. It's got kind of a pyramid shape. All right, let's pour it in here. Look at that. It changed again. Yep, now it fills up this wider space. It's probably a little bit hard for you to see that, but it's in there. All right, well, it seems like water must definitely be a liquid because even when I pour it into the skinny vase, it changed its shape again. All right, well, let's leave it over there for a minute. What about mouthwash? Do you think that's a liquid? You're right, you can't swallow mouthwash. It's for grown-ups. If you have kid mouthwash, you can't swallow it. You can just swish it. That's right, though. When I put a little bit of mouthwash into my mouth and I swish it, it moves around my mouth and it goes in the shape of my mouth. It must be a liquid. Because when I put a jawbreaker in my mouth, it doesn't change its shape. Now, if I put food in my mouth, it's a solid, but it can change its shape because I grind it with my teeth. That can change it. Yep, definitely a liquid. See, it took on the shape of the cap. All right, even though it's a different color, it's still a liquid. Let's pour that back in so we don't waste it. All right, what about something like this? What about this glue? Might be a tricky one because I can pour the glue, can't I? I can pour it out like this. We can watch it kind of drip down. And I can watch it drip down my plate. Do you think glue is a liquid? It is, but it's different than water in this way. Do you see how slowly the glue flows down the plate? If I put some of the water on this plate, watch, I'm gonna make a mess really fast. Yeah, it flowed very quickly down the plate. It just, whoop, look at that. That's not what happened with the glue. The glue had a very slow flow to it. It's still a liquid. How about our hand soap? Let's take a look at this and see if it changes its shape. Right now it's the shape of this container. I'm going to pour a little bit on my plate. Oh, look at it. It's flowing down the plate. It's changing its shape. Now it's moving even more slowly than the glue did. We call this a very thick liquid. There's a big word for this. You know that? It's called viscosity. The viscosity is how slow or fast something can flow or move. All right, well, we found out a little bit about liquids taking up space, right? Or actually, we found out about them changing their shape. Now let's talk about them taking up space. Do you think we can prove that? Let's take this cup, and I'm going to fill it to the brim. I'm going to pour this back in here. Where did I pour the rest of my water? I think there's some in here. I'm going to pour this back in here. Okay. Did I get all my water back? I guess I spilled some of my water, didn't I? Okay. So this cup isn't all the way filled up, but it's pretty close. I think our experiment will still work. Now, if I put some rocks into here, what do you think is going to happen? Okay, what do you think, Benjamin? You think I'm going to have a mess? Why do you think I'm going to have a mess? Oh, interesting. All right, let's test what Benjamin just said. Here I've got a stack of napkins, right? And Benjamin thinks that if I put some solid rocks in here, some of the water will flow out because the water has been taking up space. So if I put rocks in there too, it's going to not have enough space and water is going to flow out. I'm going to take a handful of these fun little colored glass rocks. I'm going to fill it up. Uh-oh, did you just see what happened? Let's get a closer look. I've got a very, very wet, drippy napkin now. That's because the water and the rocks, they took up space. All right, well, we talked about liquids. We talked about solids having matter or taking up space. You want to look at one more example? Okay. Let's look at this. Ooh, that made a squeaky sound. I'm going to get this clear container, and I'm going to put these in here. You see that? All right. And I'm going to pour a whole bunch of those in there. Can you see how it's taking up space? It's getting full. Yeah, it is. You know, we can measure how much how much space it takes up. We can measure the mass of something. That's how much space it takes up. And you can see on there, there's different measurement marks on there. Okay, but if I keep adding more, it's going to be like the water. Eventually, no more are going to fit. Look what happens. These start falling over because each of these is taking up space. So even if something's little and it's in a big container and it looks like it's taking the shape of the container, these actual little glass pieces didn't change their shape. Okay. Oh, you wanted to see some more examples of solids? All right. What do you say? Is it a solid? Yeah, it takes up space. And when I put it into the same jar that I put the water in, look at, she doesn't change her shape. She's still the same. If I put this block into here, look, it's a solid. It didn't change its shape. It's a salad. All right, let's talk about the last one. And I might have to take a little field trip across the room because I think I left my other materials on the other desk. All right, you start thinking about whether you think a gas can take up space or not. Because remember, in order for it to be matter, it has to take up space. So you start thinking about that, and I'll be right back. Can you hear me looking? Oh, I'm looking for my one tool. There it is. All right. We're going to use these three things to help us decide if gas can take up space. All right. Well, did you notice, boys and girls, that when you blow through your mouth, you can feel something, can't you? Do you see anything there? No, you didn't see anything coming out of my mouth, did you? So it's hard to prove that something's there. But watch. If I use this balloon, I'm going to do the same thing. Let's see what happens. Oh, look. I started to fill up the balloon. That's right. The air from my mouth filled up to the balloon, and it took up the space inside it. What about this little toy we were looking at the other day from the science kit? Why do you think this went out? I wasn't touching it. You're right. It was the force of the air taking up space. So the oxygen, the carbon dioxide, and all that stuff I'm breathing out is a gas that takes up space. Want to look at one more thing? Let's look at our bubbles for a minute. Let's see if I can get the bubbles open. All right. Now, the bubbles right now are liquid, right? Can you see them drip off? I'll just pour a little bit. And I don't want to wash that container right now. Let's just pour some like this. See that? It's a liquid. But if I blow into the liquid solution, that air fills up the space inside the bubble. So gases also have mass. They take up space. All right, boys and girls, let's take one last look at our book to make sure we got everything. We talked about how there are solids that take up space. We talked about liquids take on the shape of what they're in. And we talked about how gases also take up space and they can change their shape. All right, next time we talk about matter, we're going to talk about how matter can change. It doesn't always stay the same, does it? Sometimes some things might change the kind of matter they are. Yeah, we're going to talk about how that happens too. All right, boys and girls, go ahead and see if you can fill out your page. I'll show you one more time what it looks like. It looks like this. See if you can draw some examples of solids, liquids, and gases. They don't have to be the ones that we talked about. They can be something different. All right, very, very good, boys and girls. Keep thinking about that world around you.